Okay, second video for R5. We're going to add and subtract fractions. How fun does that sound? Okay, once again, let's take a little trip back to elementary school. If you were adding fractions, let's keep it simple first. If you had 1/3 plus 2/3, remember, for adding and subtracting, you need common denominators. This one already has one, so your answer would be 3/3. But if they didn't have a common denominator, you would have to find one. Do you remember this? So you'd have to find a common denominator, common multiple, least common multiple of 3 and 2. So your common multiple would be 6. That means you have to multiply this one by 2 top and bottom and this one by 3 top and bottom. Do you remember doing that? So that would become 2, 6 plus 3, 6. Final answer would be 5, 6. Okay, we're going to use those same concepts, but uglier. Okay, let's start with number 6 here. I look at my denominators I'm adding. So if I'm adding or subtracting, I have to have a common denominator. So I look at my common denominator. Oh my goodness, it's my lucky day. They're the same. So my common denominator just stays 3x plus 2. And all I have to do is add like terms on the top. So I have 7x plus x. That's going to be 8x. And then 8 plus 4 is 12. You can leave it like that. Some of you might be thinking that I have a GCF in the numerator. You could do that as well. Either one, I don't care. My lab accepts both of them. But if you did pull out a GCF on the top, maybe you were thinking something was going to cancel, but these two factors are different, so nothing cancels. So either answer is okay. Okay, the next one, number 7, does not have a common denominator, and I need to get a common denominator. So let's start with the numbers 9 and 6. I know some of you might be thinking 54, and you can do that, that's fine, but you usually want the lowest common denominator, the least common denominator. So I'm going to pick 18. I can multiply 9 by something and 6 by something to get 18. So 18, and then you want to pick the biggest exponent, so I'm going to use x squared. So 18x squared is going to be my common denominator. Okay, so this first fraction, I need to multiply by 2, because 2 times 9 is 18, and I wanted 18x squared to be my common denominator. And then on the second fraction, I need to multiply by 3x. The 3, because 3 times 6 is going to get me 18. And I only had an x in the denominator, so I needed to multiply by an x so that I could get 18x squared as my denominator. Okay, so now they both have common denominators. I can add. So I really just add the top, and the bottom just stays whatever your common denominator is. So the top is just going to be 10 plus 3x. Nothing cancels. I don't have a GCF. You're done. Number 8, I'm adding. I need a common denominator. So I look at my denominators, and they're so close, but they are not the same. They're actually opposites. In the first denominator, the y is positive, and in the second denominator, the y is negative. In the first denominator, the 2 is negative. In the second denominator, the 2 is positive. So they're exactly opposite, but they are not the same, and I need them to be the same. So since they are just opposites of each other, I could just multiply one of them by -1. I don't care which one. I'm going to do the second one. If I multiply this one by -1, but whatever you do to the bottom, you got to do to the top. If I multiply that bottom by -1, I'll have y minus 2. So now they are common denominators. So now that I have common denominators, the bottom just stays whatever the common denominator is, and the top you just add or subtract. So you can put y plus -8, but let's be more sophisticated. Let's just put y minus 8. There's your answer. The y's do not cancel. Don't break up the families. Your final answer is y minus 8 over y minus 2. Number 9, it's a little uglier. You're subtracting, so when you add or subtract, you need a common denominator. And I need to factor before I can see my common denominator. So factor both of your denominators, and let's see if we can find a common denominator. Okay, I factored both of them. This first denominator, I found two numbers that multiply to be -12, add to be 1, did my thing. My factors are x plus 4, x minus 3. The second denominator is a difference of 2 squares, so I split it up into x minus 4, x plus 4. So now I'm looking at both of my denominators, and I'm trying to find an LCD, least common denominator. So what I usually do is write down everything I see in the first denominator, so I'm going to write that down. And then I look at my second denominator and write down anything different. Don't repeat yourself. So like I already have an x plus 4 in my common denominator, so I don't want to rewrite that. But I don't have an x minus 4, so I'm going to write that. So my common denominator is all of these factors. It's x plus 4, x minus 3, and x minus 4. I want all of my denominators to look like that when I'm done. Okay, let's start with this first fraction. I already have the x plus 4 and the x minus 3, but I don't have the x minus 4. So I need to multiply top and bottom by x minus 4. Now I look at my second fraction, my second denominator. I already have the x minus 4. I already have the x plus 4, but I'm missing the x minus 3. So I'm going to multiply x minus 3 top and bottom. Okay, so I have my common denominator. Both denominators are the same. Now I just have to worry about the numerators. So this first fraction, I'm going to distribute a 4x. So that's going to be 4x squared minus 16. And then be careful here because you're really distributing a negative x. Or if you prefer, you could change that to plus and negative like you did back in, I don't know, pre-algebra or something. So you're distributing a negative x. So it's going to be negative x squared plus 3x. All right, sorry, that was supposed to be a 16x right here. I just wrote 16, but I changed it to 16x. Okay, so then I just go along the top and see if there's any like terms that I can combine. So 4x squared minus x squared, that's going to be 3x squared. And then I have a negative 16x and a positive 3x, that's going to be negative 13x all over my common denominator. And you're done. If you want to pull out a GCF out of the top, I know you can pull out an x. Some of you want to do that, that's fine, or you can leave it just like that. Okay, last one and I'll leave you alone. Man, look at this one. This is awesome. You have fractions within fractions. This is called a complex fraction. Essentially, it's just, this top part divided by the bottom part. You have a fraction divided by a fraction. It's essentially just a keep, change, flip problem. But before I keep, change, flip, I need to change the numerator into one fraction, and I need to change the denominator into one fraction. Okay, let's just look at the numerator. If I want to subtract those, I need a common denominator. I can put that 6 over 1. My common denominator is k. So I need to multiply that 6, top and bottom, by k. Now it has a common denominator. I'm just talking about this numerator here. Now it has a common denominator of k. So I have 6k minus 5 over k. Now I got to do the same thing for the denominator. I can put this 1 over 1. I need a common denominator, it's k. So I need to multiply this 1 over 1 by k, top and bottom, so that I have a common denominator. Okay, so now I've got a single fraction on top, a single fraction on the bottom. I'm dividing. I'm doing 6k minus 5 over k divided by 1k plus 5 over k. So it's a fraction divided by a fraction. Keep, change, flip. So I'm going to keep my first fraction, 6k minus 5 over k. I change division to multiplication. And I'm going to flip the second fraction. So it's going to become k over k plus 5. Now I look to see if there's anything I can cancel. My k's cancel. Final answer, 6k minus 5 over 1k plus 5. You don't really need that 1 there. You can just make it k plus 5. And that's your final answer. Okay, R.5 done. Do your homework, please.